Hi guys, it's been a while, but this is Mr. Fernando, and I'm here to go over the polynomials review, as well as go through some extra practice problems. So if you're skipping around to see a specific question, just be aware that closer to the end of the video, I'm going to be not showing just the review. My plan is to also show you guys just some extra practice problems. So we have some extra combining polynomials, addition or subtraction. Some multiplying ones, and then some, of course, like the factoring ones. Just again, if you're wanting to see more examples, I'll probably have to tell you guys to pause if you want to try it doing it yourself before you watch me do it. Alrighty, time to speed through this though a little bit. Starting with the first one, it says combine or add the following polynomials. Another way to think about this is that you're just combining like terms. So the idea here, right, is that you can combine anything that has the same exponent value or the same degree. So if you notice, I have 4x squared, 2x squared would give me 6x squared. Then I have 5x combined with negative 7x, right? So I have $5. Buy something for 7 or take away 7 would leave me at negative 2x. And then negative 9 combined with positive 8 would give me negative 1 as my final answer. Is a trinomial. For the next one, factor the following trinomial. So this is where a little puzzle thing, right? Where you're asking yourself, when you're factoring, you can go kind of right away. I guess I should be using p, not x, just because the problem has p. So p. We're looking for two numbers, right? The two numbers are going to go right here and right here that multiply to make 36, but add to make the middle term, or 12 in this case, positive 12. So that would be positive 6, positive 6. They multiply and they make positive 36, and they add together to make positive 12. If you're ever not sure what to do, I would suggest making the factor list of 36. So how can you make 36? 4 times 9, 6 times 6, 18 times 2, and think to yourself, I know that's not all of them, but as you make them, think to yourself, which of these pairs could get me to 12? This one's close. This is even better. So we have another add the following polynomials. So if I was to start highlighting things that are similar, I see that I have two terms, even though they're in the same parentheses, that are the same exponent value. And I see that I have negative 6x cubed plus x cubed, which would give me negative 5x to the power of 3. Because there's like a 1 right there, right? Let's do this right here. There's no other terms that have a value of x squared. So we literally just rewrite it. There's not combining with anything. Next, what we have here is, let's see, negative 6x combined with positive 7x. I have more positives, so I'm actually going to be left with positive 1x, or just x. Then we have just positive 9. It's left over, so you don't do anything with it. Just write it. It's the final answer. You combined all the like terms. Alrighty, this one. So again, I'm trying to think to myself, what are my two terms, or my two things that are going to give me to multiply to make 50, add to make negative 27. So the two terms in this case would be negative 25 and negative 2. You know right away that they're going to be negatives because your middle term is negative, so you know you're going to want something that adds the negative, so at least one of them's got to be negative. But I know both have to be negative because I need to multiply to make positive. The only way to make a positive is two positives or two negatives. So it ended up being two negatives. They multiply to make positive 50, add up to make negative 27. Alrighty, on this one, I like to say there's no such thing as subtracting polynomials. It's more like that there is actually like a negative 1 just hidden right here. That's going to distribute into the parentheses. So what I have now is negative 6y to the power of 3, negative 8. And I almost like cross this out basically because I like to think to myself, okay, this is my polynomial. This is the polynomial that I'm combining. I see that I have this one right here and this. because they have a y to the power of 3. They combine to make negative 3y to the power of 3. This is the only term that has a y on it, so I'm going to literally just rewrite it, 5y, and the last term, negative 8. Final answer. Okay, same idea for the next one. There's again just a negative 1 just hidden right there. Multiplies to both things inside, and I could say now that I have a positive 3x squared, and I have a negative 9. Let's see what I have here. I see that these are the same, right? They have the same x squared. So that's going to tell me that combined they make 5, 6, 7x squared. I see that this is the only thing that has an x value. So I'm going to write minus 5x, and then I have negative 9. So again, not such thing as subtracting. It's more that you're distributing a negative 1 and then combining like terms. Alrighty. Woo! Keep going. I don't know why it's writing. Let's zoom in. So facts of the following polynomial. So this is a little trick that we have when there is a binomial that has a minus as your second term or a negative as your second term. It's almost like a default where you can go plus minus as your default. You know for a fact it's going to be addition and subtraction because it's a binomial that has that negative. So let's see, I'm an x right there that we're going to include. From here, it's just ask yourself, what are the two numbers that make 81? Well, 9. And how do you make 36? Well, 6 times 6. That's it. Trick to it is just that it's a plus minus or a positive negative. Oh, the big one. To be a keynote is that on your review, you may, depending on my class, on the copies I made, you may not have had a x squared. The example that I'm doing today has the x squared, so just check your paper, make sure that you have the x squared one. If not, you have a different problem, basically. I asked you guys to add a square before the beginning of class, but maybe you weren't listening. So for this one, again, you don't need to use the table method. Some of you like to just straight up distribute and to do it all manually. I'm going to show the table method just because I think it's pretty clean. I'm just taking each one of the terms and I am going to rewrite it inside of my box right here, just so it makes it easier to multiply. I'm going to write it in a little different order, my next one. I always like writing my highest degree first. Make sure, again, that you pay attention to the sign next to it. So if it's negative or it's a plus, make sure you're noticing. So on this one, these multiply to make 30x to the power of 4. Again, they multiplied your exponents, add together. 5x squared times 2x would give me 10x to the power of 3. 5x squared times 7 would give me 30x squared. And this is the beauty of doing it in order. You can actually, it makes it a lot easier to combine. So 3x times 6x squared would give me 18x to the power of 3. 3x times 2x would give me 6x squared. 3x times 7 would give me 21x. Negative 2 times 6x squared would give me negative 12x squared. Negative 2 times 2x would give me negative 4x. Negative 2 times 7 would give me negative 14. So at this point, now we're going to start combining like terms. So this one is the only one that has a exponent of 4, so it literally gets to be all by its lonesome. 30x to the power of 4. I like to cross things out, so I'm going to go ahead and cross this out. Just because, again, you might want to think to yourself, all right, I've used it. So next, going by the next degree measurement would be our power of 3s. So I have 10x to the power of 3 and 18x to the power of 3. Combined would give me positive 28x to the power of 3. So again, cross those out, cross those out. Now I'm doing my squares. 30, ooh, wow, man, see, this is where I need kids to catch me. This should have been a 35. 7 times 5 is 35. Going too quick. double check yourself, because this one should be 6x squared combined with 35x squared should give you 41 x squared. But you also have this over here. So 41x squared minus 12 should give you 29x squared. So we're going to cross this out, 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 cross this out. Next I have 21x minus 4x should give me 17x. And then my final thing is negative 14. Big one. A lot of multiplying. A lot of combining like terms. Woo! Alrighty, next problem. So this one is just you showing me that you understand what each of the terminology means. I'm going to just go ahead and say that a polynomial, right, is all of these. You could write just about anything right here. You could write 2x. You could write 5x squared. You could write 3x squared plus 2x minus 7. Like, a polynomial is the blanket umbrella term that talks about all of these. A trinomial, though, is specifically one that has 3 terms. So again, I'm going to do 4x squared plus 2x minus 7. Again, it's your random one that has 3 terms that are separated by that plus or minus sign. Binomial is 2 terms, so 4x plus 4. I don't know. And the monomial is just a single term. So I'm just going to do just letter x. So what's the degree of the underlined term? So again, I told you guys to underline this one. It's also bolded, so maybe you knew that. So again, degree is literally just kind of talk about that exponent power. It's the highest degree in this case, and it is also just the number 4. What's the exponent of that underlined term? I'm going to jump straight to number 10 just because it also talks about degrees. In this case, it says, what's the degree of the monomial? So the whole thing together, right? It's still talking about the exponents. 3 and x, 6 would make you have a power or a degree of 9. Alrighty. Write the following polynomial in standard form. Standard form meaning that you would combine anything like terms together. There's nothing to combine here. So the default that you should always do is, all right, let's reorder this with highest degree first. Highest degree being the highest exponent. So cross this out. Next thing that we have is minus 7x to the power of 3. Cross this out. 5 plus positive 5x squared. Go ahead and cross this out. Negative 10x, and then positive 3. So again, writing from highest degree to lowest degree. Oopsies. Something just happened. There we go. So on this one again, I'm just gonna go ahead and write my terms on the outside. Again, if you know how to just multiply using the butterfly method or the rainbow method, feel free to use this. I just like using the box because it organizes it pretty well. 6x times 4x would give me 24x squared. 6x times 9 would give me 54x, and it happens to be negative because of that negative 9. 1 times 4x would give me 4x. 1 times negative 9 would give me negative 9. From here, I would now have 24x squared, because there's nothing else to combine with. And then these two can combine to give me negative 50x, negative 9. Again, just taking everything on the inside, combining what I can. Can't, just write it. Woo! Back to the following polynomial. So again, this is just another one of our puzzles. Think to ourselves, like, what are 2 numbers that multiply to make 15 add up to equal 8x? So in this, or sorry, just 8. In which case it would be 5 and 3. Again, because 5 plus 3 is 8. 5 times 3 is 15. Again, if you're not sure, always make a factor list of 15. Excuse. 1 times 15, 3 times 5. That's it. So honestly, you'd have to know that it's either going to be 5 and 3 or 1 and 15, but 1 and 15 is not going to make 8. So you know it's these ones. Alrighty, this one. What we got here? The best part about this one, you could use one of the methods from down here. But with this, right, is that we have a greatest common factor. You can divide all of these numbers by something. This one's pretty obvious. Usually you can just check the leading coefficient. In this case, you can divide everything by 2. So I'm going to divide this by 2, divide that by 2, divide this by 2. And if I did that, I could rewrite this now as x to the power of 2 minus 3x minus 18. Because again, I divided it by 2. I factored out 2. From here, now it's just one of our puzzles that we've been doing over and over and over again. So again, you want to think to yourself, what are two numbers that equal negative 18 and add up to the negative 3x? This one again, make your factors list. 6 times 3. We have 18 times 1, 9 times 2. I'm probably missing one right now. I'm honestly not sure. Oh yeah, I'm blanking. Sorry. But in this case, right, this one is a good candidate for getting me to that. This one's definitely not going to get me there. This one's not going to get me there. So we got to think of some combination where one of them is negative and one of them is positive, because I need to make a negative 36, so they multiply. One of them has to be negative, and it needs to get me to negative 6. So I'm going to say it's going to be positive 6, negative 3. Those two multiply and then give you a negative 36. Sorry. So sorry. Negative 18. Negative 18. These two numbers multiply to make negative 18 and add up to make negative 3. Sorry, I should have crossed this out after I factored out. I divided by 2, so this is what we're working with. Two numbers multiply to make negative 18. Two numbers that also add up to make negative 3. Which is not true. Oh my goodness. Mr. Fernando, what are we doing? What are we doing? It is negative 6 and positive 3. Whew. Rough out here, not rough out here. So in this case, we have negative 6 and positive 3. On this one, again, figuring out what we can divide out immediately. I can divide by 4. So I'm going to take 4 out of my thing right here. So I have x squared plus 6x minus 27. Because again, I divided all 3 of these by 4. So these are all going to be my new things that I have here. Final answer is going to have a 4 on the outside. And we will be then also doing what are the two numbers that multiply to make negative 27, two numbers that multiply to make negative 27, two numbers that add to make positive 6. So again, let's see, this one again, it's hard to think about, but I'm going to say it's probably going to be 9 and 3. I'm going to say it's probably going to be positive 9 and a negative 3. They multiply to make negative 27, added together, they make positive 6. Whew, man, it is hot in here, and I have just been repeating myself over and over again. Doesn't make an excuse. The answer's been right so far. Sorry if I caught you off guard with anything I did wrong. Alrighty. So if we provide you one of these box methods, know it's because that the leading coefficient is higher than 1, and you can't immediately divide all 3 of them by something. So you can't divide all 3 of them by something, which means that we have to use some sort of method. I know some of you like to use what's called the fish method. I don't know how that works. So I'm gonna be showing these two. Right away, I like filling out what information I can. I know that the first term goes here, last term goes there. I know that the middle term goes right here, and that when we multiply these two things, the first and last term goes right here. So this is where the puzzle comes in, right? What are two numbers that multiply to make negative 4 and add up together to make 3x? That's going to be 4x and negative 1. They multiply to make negative 4, add it together, make positive 3. Those two pieces that we just created get to be put into our factor box. From here, we start to ask ourselves, what can we factor out in all directions? So right here, I'm factoring up. What can I take away from both terms? I can divide both of them by 4, and I can take out an x. On this one, I can divide them both by negative 1, or I can take out a negative 1 for both. You always want to take out negatives whenever you can. Going from right to left, I can take out a x. I can't divide by a number, and they're not both negative, so I can't take out the negative, but they both have an x that means I can take away from. For this one, you can't technically divide by any number, and you can't take an x because they don't both have one, so it's just a positive 1. And so this is our answers. 1 parentheses, 2 parentheses. Final answer being 4x minus 1 inside of parentheses, and then x plus 1 inside of another parentheses. Okay, let's do it again. So, again, what information can I fill out? I can fill out my box immediately with my first and last term. I can fill this in right now with my middle term. And I can multiply the first and last term to get to 18x squared. And this is where the puzzle comes in. Again, I feel like I'm always asking this question. 2 numbers that multiply to make 18 add up to make positive 11. In which case, it's going to be 9x and 2x. 9x, 2x. Okay, what can I start factoring out? Well, I can divide both of these by 3, and I can take out an x. Going this up way, I'm going to take a 2, because I can divide both of them by 2. Going to right to left, I can divide both of these by x. Going from right to left, I can divide both of these by 3. So, final answer is 3x plus 2. And then I have x plus 3. And that is the review. That's exactly what the test is going to look like. Yeah, so those are all the test review questions. I'm going to go ahead and speed through, make sure I'm still recording, or I'm going to be so mad. Still recording. Let's multiply. So again, when you have a problem like this, multiplying means, right, that it's like the distributive. This will be multiplying both things, and so will this one. I personally like still using the box method no matter what, meaning that you put each term on one of the sides of the boxes and you multiply, right? This would give me 6x. This would give me negative 10x, because negative 2x times 5. 10 times 3x would give me 30x. This would give me negative 50. And then you combine like terms. Oops, I forgot the square here. God, man, making mistakes all over the place. 6x squared. These combine to make positive 20x. And then negative 50. That's an ugly 5. There you go. That is a multiplying one. I'll do another one that has 3 terms in it. So again, you're gonna have to make maybe like a bigger box for this one. So this one. So let's see, we have x squared, 5x, and positive 10. On this one, we have negative 4x and negative 3. I don't know how I messed this box up, actually. That's awkward. It's a really ugly box. Sorry, y'all. I'll just make this bigger. Negative 4x and then negative 3. Again, awkward looking box. I'm sorry. But multiplying them, what we have, right, is negative 4x to the power of 3, because again, when you're multiplying, the exponents combine. Negative 4 times 5x would give me negative 20x squared. Negative 4x times 10 would give me negative 40x. Negative 3 times x squared would give me negative 3x squared. Negative 3 times 5x would give me negative 15x. Negative 3 times 10 would give me negative 30. Well, let's see what we can combine. This is the only one that has a power of 3, so I'm going to literally just write it all by itself, all by its lonesome. This one and this one, though, both have a squared, so you can combine them to make negative 23x squared. this one and this one can be combined because they both just have x, meaning it's going to be negative negative 55x. And then finally, last term that has no variable, negative 30. Nothing else you can do from here. Okay, that's multiplying problems. Let's do some adding. I'll do these three pretty quick. Oopsies. So let's see what we got. Looking at my like terms, right? I have 1 book, 4 books, means I have 5 books. Oh, Miss Calabata $10. I owe Miss Bricker $3. In total, I owe people 13. So again, this was a little harder as soon as we start seeing variables with exponents. I know some people freak out, but again, you can think to yourself that this x has an imaginary 1 right in front of it. I have 7 of these, and I have 1 over here, meaning I have 8 total x squareds. On this one, I owe someone 1x, and I owe someone 1x over here. So in total, I owe 2x. And then finally, the negative 2 is all by itself. So I should have told you guys you could pause, try these problems, my bad. So on this one, again, there's a negative 1 technically right here. Boop, boop, boop. So again, distributes, and that would give me positive 4p squared. This would give me a positive 1p, and this would give me a negative 3. And I like to, again, cross this out, basically. I don't want to even look at it. Because now I can go to myself and think, okay, this and this can combine. That would give me 5p squared. I have 1p right here, and I have another 1p right there, meaning I have 2p. And then positive 3 minus 3 means that it's going away. I could write plus 0, I guess, if I want to, but no need. All right, let's do some factoring. All righty. Now let's see how quickly Mr. Ferrand can do this and not mess up. So again, these are the ones where, again, you're asking yourself the question, what are 2 numbers that multiply to make that last term, but add up to make the middle term? So in this case, one needs to be negative, 1 needs to be positive, because then again, I need to make a negative 12. But they need to add up to 4. So in this case, what am I doing? I think, again, if I really needed help, I would go, okay, I could do 4 times 3. I could do 6 times 2, 12 times 1. Which of these pairs is going to get me to 4? I don't think this is going to get me to 4. I don't think this is going to get me to 4. This has to. So yeah, it's going to be positive 6 and negative 2. Because again, 6 minus 2 gives me the 4, and they multiply to make negative 12. Let's do this one. Let's see, how can I make negative 54 and add up to negative 3? Again, well, frick. I'm going to do 9 times 4 can get me there. I can do 27 times 2. I don't think that's going to be it. Man, clearly I'm missing something else. What am I missing? What am I missing? What am I missing? Oh, Mr. Fernando, this is embarrassing. You got to be able to do this. What are we doing? What are we doing? 2 numbers that multiply to make 54. Is it 3 times something? 3 times... Oh, my goodness. Let me just... I'm going to blame the heat. Oh, my phone. Oh, hey, this is not my fault. There we go. Well, 3 and 18 do work, apparently. What else, man? What else? 54. How do you get negative 3? How is that even possible? How is that even possible? What other ways can I do this? Bruh. What? Dude, it's the heat. It's the heat. 9 times 6. What am I doing? 1 has to be negative. So I'm going to say it's probably going to be positive 6 times negative 9. They add up to make negative 3, multiply to make negative 54. Durr. Man, too much math, guys. Too much math. I'm just going to do one of these just because, again, truly, I am clearly just not doing well right now. Goodness me. Let's see. So again, what can I fill out? I know that the 4x squared, I know that the 5 goes right here. These are going to make 20x squared. This is going to make negative 21x. Oh man, here we go. Okay, wait a minute, hold on. So they need to multiply to make 20, add up to make negative 21. What are we doing here? So I think, oh, duh, it's gonna be negative 20x and negative 1x. They multiply to make negative 20, they multiply to make positive 20, and they add up to make negative 21. I feel so good about myself now. Negative 20x and negative 1x. All right, what can I factor out? I can factor out an x going this way. I can factor out a 5 going this way. Going this direction, I can factor out a 4x. And finally, going this way, I can factor out a positive 1. So in this case, final answer would have been 4x plus 1 and x plus 5. Hoogly boogly. That's a lot of math, guys. I'm tired and I have a class in like 3 minutes. Good luck on a test.